Very good evening, everyone, and once again, welcome back to the session. So, we are dealing with regression topic, right? We have started with few of regression concepts here. So, it's like the last question was, what are the challenges of linear regression? Now, when you build a model, right, you are building a model here, and when you think, right, your model is perfect. If your linear regression model if linear regression model is perfect, so what do you infer from that? From the results. Yeah. If the linear regression model is perfect. What is the interpretation be of this? Whenever you feel that, yeah, it's a perfect model. Okay, what happens if the train error is 0? What happens if the train error is 0? So the test error depends on what? So the test error depends on test data. If your test data, what you can say is an exact representation of your train data, there is a chance that you would have the test error also being 0. But always this is not the case, right? Though you have a train error equal to 0, we never get test error also being 0, right? So it is perfect. When you say it is perfect, definitely the train error is 0 and you get a very good accuracy, right? Okay. Now, if at all you are talking about regression, right? We say that multicollinearity exists. If multicollinearity exists, what happens to the overall F test? If the multicollinearity exists, what happens to the overall F test? Yeah. If you have multicollinearity, what happens? What happens to the F test? What happens here? Your F test value is a valid number, but the hypothesis test of individual coefficients, you assume that it is not valid. It's not an assumption, it is not valid. That's it. F test is valid. But if you have a multicollinearity problem, hypothesis test of your all the coefficients, individual coefficients is not valid. But what is this F test statistics? What is F test statistics? What does it give us? What inferences you draw from that particular calculation or that particular what you call it as F test? Yeah. What is F test in regression? What does it do? Yeah, F test in regression, it compares the fit of the different linear models. So it can access multiple coefficients, what you can say, simultaneously, right? So F test of overall significance is a specific form of F test. What is the importance of F test now in linear model? How is it important for us? How is it important in linear models? How is it important in the linear model? Yeah. What is the importance of F test in the linear model? We understand that yes, it compares the fit, it's the right or correct with different linear models. That is the thing what we do in linear model. But what is the importance here? So the importance means it's very crucial one, right? In sense that all the tests, it tests the goodness of your model. When you reiterate the model to improve the accuracy with changes, it this particular F test statistic proves its utility in understanding the effect of overall regression. So your overall regression, how it is, the best or not, is interpreted with respect to your what you call it as F test statistics. Okay. So when you talk about the goodness of model, why do you think we are saying that multicollinearity exists? What is the reason behind multicollinearity? What is the reason behind multicollinearity? Why that particular problem arises? What is the reason behind this? This issue would arise. If at all you create dummy variables, right? When you create dummy variables, this problem, there is a 101% chance that there would be multicollinearity problem. And also, when you have the repetition of same kind of variables, right? When you have the same kind of variables, maybe there is some relationship between two variables. You have 20 variables in for consideration as columns, but what happens is that maybe there is a relationship between these 20 variables or not is also checked. If your input variables are having some relationship, right? What is the need of using both of them? It becomes a heavy load on your model, right? You have to put or you have to consider a few things and check, does it really have any impact on your output Y? Is it really important for the analysis of predicting that particular output variable? That is checked here, right? So it is important that you need to check the collinearity And the reason is always that if at all you have some dummy variables, there's a chance of getting this particular problem. So if you go for PCA, does a problem of multicollinearity resolved? Or if I make it as does PCA, what is PCA? Yeah, exactly, Subhajit, speed and distance. So does PCA solve this issue? Solve the problem here of collinearity? You have to resolve the issue, right? Yeah. How do you resolve the issue? Definitely PCA would help us to solve the problem of collinearity. What does it do? The number of predictors are cut down, or you can say that they are compressed. Right? You're not cutting down, actually, you're compressing them. Compressing your columns, compressing your variables. Right? So if you compress or you minimize or yeah, compressing the number of predictors to a smaller set of columns or features, resulting in uncorrelated components. Right? Results in uncorrelated components. Suppose you have to remove highly correlated predictors. How you can do that? Yeah, exactly. Dimensionality reduction is a solution for this collinearity problem. Very good. But how do you remove these highly correlated predictors? Yeah. How do you remove this? Is there a way to check whether your input variables are having good correlation? What is the process? What is the approach you follow? Yeah. How do you remove the highly correlated predictors? So you check your variance inflation factor, VIF. And then secondarily, you go for AV plots. And then you take a call what to do with that predictor, two predictors. Right? So what do? You do a VIF. You calculate VIF. What is VIF? VIF is nothing but variance inflation factor. And you have something called as AV plots. And you finally take a decision what to do with the predictors because they are highly correlated. You have to delete it. You have to just maintain that in your data set for your analysis or what. Right? Why are you? What is this EIF? For what all process you are using this VIF? VIF is helping us in determining what? Let me put it down here. Variance inflation factor. Yeah. It is useful in determining what? What all processes I can say? What process? So VIF, it quantifies what? So it would check, right? What does VIF do here? It would check the actually how much the variance of estimate, right? And the regression coefficient is inflated by the existence of your multicollinearity, right? By the multicollinearity. How that particular VIF is calculated? How do you are calculating VIF? What is the formula for calculating VIF? What is the interpretation of this VIF? Is it small r square or capital R square? And what is that R square called as? Sorry. Yeah, exactly. It's correct. So VIF measures how much variance, that is nothing but the square of the estimate's standard deviation, right? How much variance means the square of your estimated or estimates standard deviation of an estimated regression coefficient. That particular estimated regression coefficient is increased because of your VIF or because of your, sorry, collinearity. So if your VIF is calculated for a predictor variable, right? So if it is something like you have, there should be some interpretation, right? It should be some value is given if it's greater than 10, right? You say that you have to take a call. If it is less than 10, you take it differently, what you have to do, right? That also we'll get to see now. So what are the steps for calculating VIF? First thing is that you run a linear regression in which one independent variable is considered as target variable and all other independent variables are considered as what? Predictors. So you give, the calculation is given by the formula 1 by 1 minus capital R square, where capital R square stands for coefficient of determination. Small r square, small r is your correlation coefficient whose range is from -1 to 1. 0.85 means two variables are having strong correlation. But here it is 1 by 1 minus capital R square. It is nothing but coefficient of R square is nothing but here coefficient of determination. Right? It is 1 by 1 minus R square. Right? Okay. Do you have a package or any function to calculate directly in Python this particular variance inflation factor? Yeah. How you can calculate VIF in Python? So from which package you can pull this particular value? Variance inflation factor is imported from what package? In Python. Okay, it is from stats model dot stats dot outlier inference. From this, you are importing variance underscore inflation factor. The storage model has a particular function of calculating variance inflation factor. Okay. So when you talk about variance inflation factor, we got the formula as 1 by 1 minus r square. Now, what is a that VIF is also can be interpreted as 1 by tolerance, right? So how do you do it in R then? How do you calculate this in R? What is the package here? To calculate VIF. What is the package in R to calculate variance inflation factor? Okay, you have you can calculate in many ways here, but one is your car. Mostly we use car. Okay, why others also? We use car package for calculating this VIF factor. Okay, now we are saying R. Very good. But now what is this R square? We said that VIF is nothing but 1 by 1 minus R square. Now what is R square? Yes, it's coefficient of determination. What does it do? What you infer from that particular value given by your model? Yeah. Yeah, exactly, Subhajit. Very good. CAR package. Yeah, what is this R square? Coefficient of determination, correct. But what is the interpretation? How is it calculated and what do you get to infer from that particular value when you build the model? How the dependent variables related to individual variable. Okay. So if you write it, if you try to understand it, it is 1 minus right? Unexplained variation by your total variation, right? So R square is your statistical measure, right? That represents the proportion of the variance for a dependent variable that explained by an independent variable, right? Explained by an independent variable. Okay. So what happens if your variance inflation factor you got is greater than 10 standard? What if VIF value, when you just find it out from the respective packages in R and Python, what does that mean? What is the interpretation about the predictors here? What happens to the predictors? Multicollinearity exists. Yeah, what happens is that due to the huge variance, what happens? The interpretation becomes very much difficult, right? The interpretation becomes difficult with respect to the coefficients. And finally, there comes a conclusion that you have that particular issue. That is nothing but your multicollinearity problem, right? So whenever you get any value greater than 10, what happens if all the values you have as a predictors are greater than 10? You have some 10 or, okay, take 6 or 5 inputs are there, predictors are there. What happens if all these values become greater than 10? You can't delete all of them, right? What will you do? What should be our approach here? Okay, if one is greater than 10, okay, fine. You'll have to check it, recheck, do a kind of recheck, and you'll do. What if you have all the predictors? Yeah. You will not delete, right? You should not delete because collecting data is very, very prior thing. What you have to you have to think of, right? If you delete all the things, how do you do your analysis, right? How do you build a model here? There is something which you have to calculate and think of, which is having the least impact on Y. What is it? What is the next check point to find out, deep dive to get the predictors which are least influencing your output variable? Okay, even before we go into that question, what do you remove these intercepts while calculating VIF? Okay, do we remove intercepts while you calculate VIF? Yes or no? Very good. No. Why? VIF depends on intercepts because there is an intercept in a regression, right? Which is used to determine your VIF. If the intercept is removed, what happens to your R square? There is no meaning in calculating R square only, right? It's not meaningful. Like it may be negative also. In which case one can get VIF would be less than 1. Right? Your VIF would become less than 1. And what does that imply? The standard error of your variable would go up and it would rise. If your independent variable was to uncorrelate with your other predictors, right? So, no, you should not remove your intercepts while calculating your VIF. Okay. Suppose after you have analyzed your model, and your manager has informed that your model, what you have built, the regression model, what you have built, right? It has got some multicollinearity issue, right? How do you check the statement, whatever he gave about the multicollinearity, it's true or false? How do you check that? If at all you check that, right? Can you still build a model, a better model, without losing any information? What will you do for such a case? I repeat. So you have done, entire process is done. You have built a regression model, right? And your manager will say that, yes, your model has suffering from multicollinearity problem. How do you check that it's true or not? If at all that is true, how do you build a better model? What is the procedure you follow for this? How do you check first? So you have to check that, and without losing any information, is there a chance that you will build that particular model, better model than what you have already done? How do you check? Okay, so to check, first he said that yes, it is a multicollinearity problem. What will you do? You have to create one correlation matrix. Why you want to do that? Because you want to identify and remove the variables. If your correlation matrix would give any value between the relation between any two variables being greater than 0.85, right? That is 0.85 or 0.75 or 75%. That is, you are deciding a threshold point. That is a subjective point, right? It's up to you now. You think that, okay, it is usually one value is that we always say if your R value is crossing 0.85, you have a strong strength is good between the two variables. If you want to do 75, You can go for 85. It depends. It's subjective. So first you do that. That is one check. Then you will say that you will not say. You just go for a calculation of variance inflation factor, right? So you will come to a conclusion that the presence of multicollinearity problem is existing, right? If at all your VIF value, as we have just now discussed, it is less than 10, no multicollinearity problem. And wherever you have a value which is greater than or equal to 10, it implies that serious multicollinearity problem is there. And also what I told you, variance is nothing but variance inflation factor is nothing but 1 by tolerance, right? So tolerance also it's an indicator of multicollinearity problem, right? But removing correlated variables, definitely collinearity exists in correlated variables. You will go for you if you remove that, you will lose the information. Now, what is the next step you do? In order to retain those variables, you have to retain the variables and you have to solve the issue of this. Tell me. In order to retain those variables, what we can do? Without deleting any variable, it means that without losing any information here. You can go for regression models, right? Regularization techniques here. Lasso regression, ridge regression. And also one more option is that we can add some random noise in correlated variables so that the variable becomes different from each other. Some kind of noise, random noise is added to your variables, correlated variables, so that the variables will become at least some change would happen to the predictors here. But there's again one point to be addressed here, that is that if you at all you are adding your noise, this might affect the accuracy of your prediction also. So the approach is correct, but if you are using this approach, you have to be very, very careful. Use it carefully. The approach should be carefully used. Right? So the regression models are nothing but your L1 regression regularization technique is lasso regression, and model which uses L2 is called the ridge regression. Okay. Now, when you're talking about the cross checking, you have the VIF factor, you have to do the cross check. So how do you do that? How do you do a cross check here? There is one plot to do a cross check. What is it plot? Additional checks are done. What is that? Okay, let me write it. What is this plot meant for? AB plot. AB plots. What is called as AB plot? Exactly, Subhajit. What is AB plot? For what you will use this plots? For what you will use this AB plots? A stands for added, V stands for variable, added variable plots. Exactly. These are for your linear models. right? So these plots, why are we using these plots? You are trying to visualize, right, to see the effect of variables being added to the model. So you want to see the effect of variables being added to a model. So do this AV plot have another name? They're also called as what? What are the other names they're also called as? Partial regression plots, right? Partial regression plots, adjusted variable plot, individual coefficient plot. Right? These are your they're also named as, they're also called as this AV plot. Right? Okay. So whenever suppose you are going for R square value, right? And you have something also called as adjusted R square, right? Now, tell me what is the difference between your R square, adjusted R square. R square and adjusted R square. What does it do? Adjusted R square. Whenever you build a model, right, you get all these values, right? R square, adjusted R square, you get a P value, you get F test statistics value, right? You get the coefficients for the regression. All is you are the output of your model, what you have built. So after seeing this R square, just now we understood that R square is nothing but the coefficient of determination. But what is this adjusted R square? So R square accounts for variation of all the independent variables on dependent variate. First thing, right? It is accounts for the variation of all the independent variables on your dependent variate. And each independent variable is considered, every independent variable is considered, right, on dependent is considered for explaining the variation. But when it comes to adjusted R square, right, it accounts for significant variables alone. It will only take into consideration the significant variables alone for indicating the percentage of variation in your model. Okay, Manish says that if the variable is increased, adjusted R square decreases. If the variable is added, adjusted R square decreases. Right? And your R square, that means that whenever your variables are significant or not, right, that particular value is what you have to consider. So you have to compare both R square and adjusted R square also when you get the model summary. Okay, So we have seen that there are few techniques. You have the multicollinearity problem. You can go for PCA to solve the issue of multicollinearity problem. You have the procedure to find out the highly correlated predictors, right? You have techniques for reducing this multicollinearity problem also, right? What are the techniques? Linearly, you combine the independent variable, right? To reduce the problem of multicollinearity, linearly combine the independent variable. And partial least squares regression is done, right? PCA is done. So you are doing a performance on analysis designed for highly correlated variables. All the analysis are done to solve the issue of this, right? Yeah. What is this? R square is your coefficient of determination. How if, okay, if you have a, suppose you got a percentage 64, 0.64 is your R square value. Okay, 0.64 is your R square value. So what does it interpretation comes? When you have 100 data points, your model will be able to predict only 64%. Like 64% correctly it predicts, right? 0.64, right? That is the interpretation, and that is also called as your coefficient of determination. So what does it mean? It would take the, it is calculating the variation. What is your dependent variate and what is your independent variables? It cross checks that. It will check the variation of all these independent variables on your dependent variate. What is a dependent variate? So it would take every variable, not take a single variable, all the variables it takes for explaining the variation. Because ultimately when you get R square only, you would get your variance inflation factor, right? Right? Now what is this adjusted R square? If at all you have the problem, when you get the model, you'll get this and you get this also. You have to cross check. And if you cross check these two difference should not be maximum. Right? The difference between your R square and your adjusted R square should not be maximum. Okay, if that is there means you have to cross check with your variables. It's nothing but a version of R square only. So what is that, if at all, as you people said that you are adding a variable, you keep on adding a variable, right? That is nothing but a new variable is added, means new predictor is added. If that particular variable when added, if your model performance increases than whatever you have expected, right? If you suppose you have y equal to x1, x2, x3. So you have added one variable x4. You are expecting something. The predicted value or the accuracy is what you are expecting. If that accuracy increases more than what you have expected by chance, right? Then your adjusted R square value would increase. Right? Again, your adjusted R square would decrease if your newly added variable is having less approach here. So what does it mean? Adjusted R square is nothing but your modified version of your R square that has been adjusted for the number of predictors in the model. Right? The number of predictors in the model, the effect of the predictors on your model. So what does it mean? These two should be nearly equal. If you are adding it, this would increase. If that particular value, whatever, if it would decrease when predictor would improve the model, when it did decrease than you expect. Right? That's why you are saying that it will account for the significant variable. So it will indicate what is the percentage of variation in the model when a new variable is added. Right? When you add a new variable. So you keep on adding the variables. This effect should be there. You put an I now. That is making really sense to add that particular new variable. That is checked using this here adjusted R square value. Okay. Now, what is a baseline model, friends? What is baseline model? Vanilla model. So the model which is built, okay, let me put it here. Yeah. So it is nothing but a model with only intercept and no slope. Right? The model which is built with only intercept and no slope. Okay. So what is this beta naught then? You have the equation, right? How do you write your equation? Y is equal to beta naught plus beta 1 x. What is this beta naught? What do you call it as? Intercept. Okay, in this context, for a baseline model. For a baseline model. Yes, okay. Yeah, beta naught is nothing but your base estimation. As you told, it is a vanilla model. So when you're not passing any variables, right? What happens if you're not passing any variables? The model what you have built is nothing but your, yeah, coefficient. For what coefficient? I didn't get that. So no input variable is passed, which is influencing your output, right? So when you say that beta naught, when no variable is there, it is nothing but the average, right? Which is not affecting your estimate, then that is nothing but, you call that beta naught as average. For univariate, it is called as average. Beta naught is called as average for any univariate model. It is your average. Beta 1. What is beta 1? Beta 1 is nothing but the value of the change in y. What is the value which is changing? Change in y when your x-axis is altered by 1 unit. If your x-axis is altered by 1 unit, what is the change in y? It means that x is changed by 1 unit, your y would change by beta units. X changes by 1 unit, your y would change by beta units. Right? So that's about your beta and that's about your slope. Okay. So in multilinear regression, if you build a model, you are getting the, what you call it as, p-value. Okay. So what happens if your p-values, let me put it here, in MLR, in multilinear regression, if you are building the model, You get p values, right? If is greater than 0.05. How shall we proceed? How shall we proceed for that? So first, what will you do? You will check for something called like influential observations, right? If your p-values are greater than 0.05, right? Then try to check and test for influential observations using influence index plot. There is nothing but first thing is that when you do that particular plot, you get 4 graphs. Remember Cook's distance, right? When you take Cook's distance, that Cook distance, which is wherever you have greater than 0.5, it means that your observations are influential. You have again second plot, which is nothing but just studentized residual. If a point on the plot is very, very different from the rest, separately you have that particular point, right? From the rest of the other data points, then you call it as influential observation. Right? You have something called as hat values. Any observation which is standing out from the remaining point, that is nothing but your hat value plot. That is also an influential observation. So all these 4 would give you the same set of observation. You remove that particular observation or record and take a call. Bonferroni p-value also, right? Like you have a hypothesis testing. If your observations are less than 0.05, they are considered to be influential. You get a 4 plot when you do influence index plots. Right? You get 4 plots here when you go for this. Okay, now, so whenever you are calculating all this, right? Now, what did we all discuss for today's session? Something about VIF, few issues, right? Challenges when you build any linear model. Index influential plot is that no, any of the thing which is happening with respect to your output. You have something indexes, the name only, right? Influence index plot. If at all your v value is greater than 0.5, you shall proceed with all these values. This plot would help you to depend on that. So today, what we have discussed with started with multicollinearity problem, correlation, variance inflation factor, R square, adjusted R square, right? Adjusted R square. So you have understood R square and adjusted R square, right? So every time you add any independent variable to your model, R squared increases, even if the independent variable is insignificant, right? It never declines, but adjusted R square increases only when the independent variable is significant, and that is affecting your dependent variable. So when you go for VIF, right, VIF should be greater than 10, then you have to take a call on which observations you have to delete, which is having maximum collinearity problem, right? Yeah. So I'll stop here. So next week would come with next set of questions. Thank you all. Thank you.
Yep, thank you so much. Hey, hello everyone. We shall be starting the resume preparation session in a bit. If you may give me a moment, I would like to pull up certain documents. one or two resume if I can pull out. And I wish to explain you on how a resume should not be prepared. So just give me a moment while I pull up a resume. I wish to remove the references from the resume. So just take a moment. Just give me a minute while I try to pull up. I just found a resume. Hope it's oops. Hmm. Okay, I would hide certain details and then let me download this and let me rename this. All right, so let me now share my screen and speak about resume preparation. Friends, whenever you want to create a resume, basics such as the side headings. On a lot of resumes, I've observed this that they have these side headings, okay, which you see. And all these side headings would be in different font or different size or different color. That reflects very wrong precedence. Remember one thing, that resume is your face. The potential recruiter or employer is not looking at you, but is looking at your resume, and this reflects your face. This reflects you. So you should ensure that the basic housekeeping tasks are properly done. And number one is ensure that the font and the font size for that case, and the font type and the color is same for all side headings, or for all sections rather. Very, very important. Second thing is the sections, heading of sections must be of bigger font than the text within that. What do I mean by this? So you have this, what if this section, the font and this font is the same? It doesn't look good at all. Okay, so that's very important. And the second thing is, for that case, I've just randomly picked up this, okay? And this is one of the person who's applied. It's pretty good resume, but there might be few things that we should take care of, okay? And what are those things? Third thing is grammar. Okay, so you should take care of the grammar basically. And grammatical mistakes are something which will take you down, pull you down completely. For example, there should be a full stop here. That's something that you should be aware of. There is grammar check on almost all the Word documents, be it Google document or Microsoft Word document, you'll have the spell check. Please do that. For example, if you have an abbreviation, it should end with a full stop. In certain cases, just as an example, what happens is, if this is a date, they say 01 space like this, and when they write 30, for instance, there won't be a space. Inconsistencies should be addressed. Inconsistencies should be addressed. Second, full stops should be taken care of. It might sound as if this is English section, but yes, it is. And whenever you have this brackets, right, for example, advisors, then you give a space, and then, okay, after a space, you need to open that bracket. And then within the bracket, don't give space again, close it. After comma, there has to be a space. Very important. Sometimes I see double spaces. Please do not do that. Be careful. This is going to reflect your, your face, basically. Your face is going to reflect on your resume. Insurance company. Whenever you have company names like that, please ensure that you put the words in proper case. Proper case means insurance should be written in this way. Insurance company limited. But when you look at this, I is in small, C is in small, etc. And it should end with the full stop. It's a sentence, not a bullet point. If you have bullet points, like what you see here, bullet points do not end with a full stop. But when you have paragraphs, paragraphs should end with a full stop. And look at this, Shiv Shivani. Right? This is name of a college. All the proper nouns should be in proper case. Institute. This is exactly how it has to be. At one place, you are putting everything in proper case. Then underneath that, you're giving in uppercase. Then the next immediate thing, you're putting it in uppercase. Then in not even in proper case. How would it reflect upon a person who's looking at this? Somewhere you put uppercase, somewhere you put proper case, somewhere you don't put, you put everything in lowercase, doesn't work. Is it living or leaving? So all these are the kind of things that you need to focus upon. There should be consistency. If you want to put all the college names in caps or uppercase, do that consistently. Here, here, and here. Everywhere it should be in uppercase. If you're putting everything in lowercase, do so. But one would be in uppercase, one would be in lowercase. No, it doesn't reflect upon your resume properly. These are a few basic housekeeping tasks that you need to bear in mind. You have to consider, okay, management skills, communication skills, okay. Yeah, learning, L is in small. And after comma, you should have given a space. And if it's Microsoft, it's not like this mess, it's Microsoft Excel. It's Microsoft PowerPoint. And when it comes to PowerPoint, it has to be like this, PowerPoint. And if you're in doubt, I'm also in doubt now. So what I shall do here is, I shall just type and search PowerPoint. Let's see how it comes up. Look at that. P is in caps and P in PowerPoint is in caps, isn't it? If you are in doubt, do that basic search. You'll understand what should be in caps. Very important, friends. Very important. You might feel, oh my God, this is all basics. I mean, people won't look at that. Yes, they look at these things. And if, for example, I get a resume which is shabby looking, I understand how shabby that person would be, whom I'm going to hire. If person is not paying attention to, you know, the basic grammar, and if there are inconsistencies, how inconsistent would that person be whom I'm going to hire? You know what, HR professionals who, you know, shortlist the resumes are trained on these things. Companies train them on these things, saying that, hey, these are a few things which you have to figure out and just strike it away. Don't even get these kind of resumes onto my platter. We won't interview them, kind of, right? They might be having talent, but these are the basic things that have to be taken care of. Okay, next, projects. This shouldn't, see, you're putting this on one page and in another page you're starting. There is no consistency here, or there's no continuity rather. You could as well say enter, and this would have come in the next page. Okay, next. The good part is bullet points should not end with a full stop, and that's taken care here. When it comes to projects, this is, I believe, one project. This is, I believe, one project. This is, I believe, another project. But then bullet points are missing, no consistency. Okay, and I believe this is one point, this is one point, and this is another point. No consistency, and bullet points should not end with a full stop. Language is, this is not a single language. There should have been comma, space Telugu, comma, space Hindi, comma, space Kannada. Okay, and rest of the details are pretty fine. But projects, do you think should be like this? Not really. Whenever you are entering project details, please ensure that you provide a few details such as, what is the project name? There'll be a theme to the project. Or basically a brief description, one-liner about project. You can put it as project, business problem. Briefly explain. You need not call out the name of the client. You can actually say that this is, you would have done project for a bank. Okay, say you have done a project for State Bank of India. You can as well mention a leading bank in India has a problem that a lot of customers are churning out to private banks. This is a business problem. Let it be a little elaborate. After the business problem, you come up with the technical solution. In this technical solution, you are going to talk about your algorithms. I'm pretty sure on any projects, you would use a cocktail model. What do I mean by that? You will use unsupervised learning techniques. Unsupervised techniques. And these unsupervised techniques would be probably clustering. Within clustering, what did you use? Say you have used DB-scan. Mention that. Did you do dimension reduction also? Mention that. What technique did you use? And when it comes to supervised learning or predictive modeling techniques, what did you use? Did you use neural network? Or did you use extreme gradient boosting? What technique did you use? Mention those. So your project should be elaborate. Basically, it cannot be a single line. Come on, this is what you would be judged on. You will be judged based on the kind of projects you have done, what is the quality of the project, etc. Okay, in this technical solution, you can also mention whether it was a cloud implementation Or was it on-premise implementation? You need to mention that, because nowadays world is moving towards cloud, and if you have done any cloud implementation, putting that, mentioning that, calling out that strikingly would catch the attention of the recruiter or potential employer. And then business problem, technical solution, algorithms, tools that you have used. What did you use as a tool? Did you use Python? Did you use R? Maybe libraries that you have used? Not all, but a few of the striking libraries. Yeah, sure, call out. And then what was the business benefit? If you would have done a project, certainly business benefits would be reflected. For example, by building this project or by doing this project, there was a reduction in customer churn by maybe 13%. Put realistic numbers, put based on what work you have done. Don't cook up numbers. People can identify that those are fake numbers. So don't fake, not needed. We are not here to fake. We are here to represent whatever we learned in a better manner. This is how your project should be. If you're working on 4 projects, just imagine those 4 projects listed in a detailed manner in this way. Would people not be happy? They would certainly be more than happy. Okay, and having said this, you also need to focus on a few things. I'll speak from 360 Digit MG perspective, okay? On what happens after our students complete their assignments, they can automatically download certificate of 360 Digit MG from their learning management system called AI Sprite. Once you download, would you like to save it on your computer and let it be there for the rest of your life? Or do you want to let the people know that you're upskilling yourself and you're grooming your skills? If you are upskilling yourself, then go do 2 things. One is post that on LinkedIn and let the potential interviewers and employers watch that. And we ensure that our team members like it and share it so that it reaches a wider audience. Next, you go and update your resume on job portals. It could be Naukri, it could be Monster. A few of the job openings would be in Monster, a few of them would be in Naukri, a few of them would be in something else. Update everywhere on your resume. Do you know what? The moment you update your resume, and if an employer searches, those resumes which were recently updated would appear on the top. And chances are high that you will start getting interview calls. If you're not getting interview calls, then you're not doing enough. Simple. Then we also have accreditation with IBM. So you will receive an email from IBM, from us. You can log into the IBM portal, watch the videos and take the exam, and then you'll get another certificate. This is certificate number 1. This is certificate number 2. Don't wait, go post it once again on LinkedIn. Let the potential interviewers and employers come to know about that. Update your resume once again. The beauty is that those resumes which are frequently updated, Naukri and Monster and other job portals understand that they are looking out actively for job. Third, if you're a fresher, there is no harm in saying that you're actively looking out for a job. You have to mention that on your resume, subject or title line itself. Mention in the title line itself so that people who watch your profile clearly know that you're looking out for a change. Third thing is, if you have enrolled for our professional certificate training, you'll also get certificate from UTM, which is University Technology Malaysia, one of the top-notch universities. Globally, it is ranked in top 200. You'll have an exam that you need to take. The moment you pass, you get a certificate, and then again publish that on LinkedIn and job portals. Look at how active you have become all of a sudden, right? All of a sudden, you're active on LinkedIn, now Cream Monster. This is what is needed for you to get a job. Then, while all these things happen, you also start working on live projects. Live projects could be from Panasonic, or it could be from InnoDataTix. If it's from InnoDataTix, then it could be from Coca-Cola, it could be from State Bank of India, it could be from Hindustan Unilever, it could be from Yatra, it could be from Tata Trust, it could be from State Bank of India, it could be from Korean Airlines, it could be from TrueJet, it could be from HDFC Insurance, it could be from Bharti Siemens. We do a lot of projects for various clients. And you are entitled to work on 4 projects. We call this as classic 2+2. Why? Because 2 projects would be on data science, another 2 would be on artificial intelligence and deep learning. I would say deep learning rather, because anyways, even if you use data science, you end up building AI applications, so deep learning. 2+2, so there are 4 projects. The moment you complete each and every project, there will be a project presentation that you do on YouTube. On our YouTube channel, where there are close to 20,000 subscribers now as of date, right? 6th of Feb 2021, approximately, you will have 19,000 to 20,000 subscribers. They all will be receiving emails the moment we upload the video. And when you do a presentation, take that video link, post it on your LinkedIn, post it on your Facebook. Okay, and you will be notified. I mean, or rather, you would be notified. You will be notifying this to the other potential employers and uh, people who are trying to recruit. Update those details once again. 2+2, 1 project. The moment you complete another project, the moment you complete 3rd, updated, 4th, updated. Same with all the job portals. Now look at what is happening to the amount of visibility that you are creating for yourself. One is you have taken care of the housekeeping tasks. You have ensured that your resume is up to mark. Then you are ensuring that all the certificates are displayed so that with pride you can display. It's not a small feat to get these certificates. And while you work on live projects, do all these things. And you know what? You also get a certificate from InnoDataTix for project completion. Once you're done with this, please ensure that you post even these certificates. So 1, 2, 3, and +4. For each project, you'll get a certificate. So that means you'll have in total 7 certificates. 7 times you'll be posting on LinkedIn, Facebook. 7 plus 4 times the project details. You would be almost 11 times updating your resume and Naukri and Monster. All these things will happen within a span of, say, probably 2 months or 2 to 3 months. In these 2 to 3 months, you will be hyperactive. You'll not be active, but you'll be hyperactive. When you're hyperactive, there is no scope for anyone to oversee your details. Obviously, they will look at your profile. When I say they, people who want you, who want to hire you rather, and that gets you a job. Okay, and I am not looking at the YouTube. There might be a lot of questions on the YouTube channel, and I need to ask my friend if there is any. Or let me do one thing. Let me open Google. Let me open incognito mode and let me go to the YouTube channel and let's see what kind of questions. Incognito mode and let me go to the YouTube. Okay. I believe there are 13 people watching. If there are any questions, I'll be more than happy to take your questions. And if you have no questions, then I'm done. Thank you so much for staying in, and thank you so much for listening this. Is influential observation related to collinearity? No, Subhajit. Influential observation is not related to collinearity. Okay, influential observation is kind of outlier. Okay, all right, friends. Thank you all.